This presentation is about Index Engine's Cybersense product. Cybersense product is an innovative approach to cyber attack detection and recovery. Cybersense is based on using analytics and machine learning really to detect corruption due to an attack quickly and to help support a diagnosis and rapid recovery of that attack. We know for a fact that existing security solutions are not enough. Companies are being attacked. They're not 100% protected. Even if you have dozens or hundreds of security solutions, including endpoint and real-time solutions, attacks still infiltrate the data center. Also the challenge when companies do get attacked, that the post-attack recovery requires significant time, resources, and money to get businesses back operational. Cybersense Approach, it's not a replacement for existing solutions. It doesn't replace endpoint solutions or real-time behavioral analytics solutions. It adds a layer of protection. And what it does is it's really kind of the last line of defense. It looks inside files and databases to see if signs of corruption occur. So when these attacks do circumvent real-time solutions and other security solutions, Cybersense is looking at the data continually, checking the integrity, and we'll see corruption occur. Cybersense really looks and observes at how data changes over time. Cybersense can be integrated with the backup process, which we'll talk about. Backup is really gathering and accumulating changed data into one single location, and Cybersense can piggyback off that process and look at how that data is changing over time, kind of point-in-time observations of the data. Cybersense looks inside every file and every database for signs of corruption, encryption, deletion, all sorts of stuff, which we'll talk about. Cybersense uses analytics and machine learning to audit the data, so the process is automated and will give an alert out when corruption is detected. And then that's really kind of a proactive approach, but Cybersense also supports a reactive approach, post-attack diagnosis and recovery from an attack. Cybersense supports a wide range of data types, unstructured files, your documents, contracts, agreements. Those are the types of files that are typically attacked by cyber criminals. Cybersense also supports databases, Oracle DB2, SQL, Epic Cache as examples to look for signs of corruption or encryption inside those databases. Cybersense also looks at core infrastructure like DNS, LDAP, Active Directory. A lot of the attacks are on this core infrastructure that would really cripple the business from getting back up and running. So the unique feature of Cybersense is that it can support scanning of network data, but more importantly, it can scan backup images. So the data, as data is backed up and protected, Cybersense can go inside those backup images without the need for the backup software, without having to rehydrate the data, and scan the contents of those backup images and look at the data inside there to see how it's changing. So it's a very unique feature of Cybersense. So the direct scanning includes all the popular backup formats from Dell EMC, Veritas, IBM, Commvault. And again, what indexes the data inside those backup images, looking at how the integrity of the data without the need for the original backup software or rehydrating the data, which is an important feature for post-attack or incident response vendors that are using this to really look inside backup data sets to see if the data is safe to recover after an attack occurs. So a couple of different deployment options on the proactive side, which is obviously the preferred deployment option. There's a number of different scenarios. So scanning backup data, so scanning production backup. So if you've got a backup server or backup device that's protecting your data with the aforementioned backup software, you can scan those backup environments to be able to understand how data is changing over time. Dell EMC is a partner of Cybersense and has integrated this with their Cyber Recovery Vault. So in terms of deployments, that's probably the most widely respected and world-class deployment options. It's an isolated vault where you isolate your core key data environment and infrastructure into that vault. So it's kind of the crown jewels that are isolated off the network that are not even visible to cyber criminals. And then Cybersense will scan it to check the integrity of that data. So if you do ever get attacked, you'll know you have a clean, good copy in an isolated vault to recover from. And that's being sold globally today. And you can also scan network data. to look at the integrity and check the, for signs of corruption. So on the post-attack or incident response deployment, you can do the same thing. So it's a very similar concept, different workflows, similar concept, but you can scan historical backup data. So when the customer does get attacked, you can start scanning some backup sets without rehydrating it or creating a clean room to restore it, and check the integrity of it to figure out which are the backup sets that need to be restored. And then you can also scan network data. So if you're seeing data corruption within certain file servers, you can scan those servers to figure out where the corrupt data is. And it's an automated process that really facilitates recovery and cleanup. So the workflow, Cybersense proactive workflow sample is data is scanned. So the idea is you're scanning data continually, every observation. That's why integrating it with a backup environment makes sense, because backup is already doing that today, and it's gathering and accumulating and replicating and copying data, scanning that data to check the integrity of it to see if any data corruption occurs makes a lot of sense. So consider a scan and observation. So the observations occur over time. As the scan occurs, each observation will create a series of analytics, over 100 analytics that are generated, analytics that are indicative of a cyber attack. So things like entropy is one of the most important analytics that's generated. So entropy is a random disorderness of a file. When a file or a page of a database becomes encrypted, the entropy increases. So we have an entropy score from 0 to 100. When an entropy goes to 99, that signifies encryption. So that's one of the statistics. A number of them include file corruption, such as changing the file extension, which doesn't match the header of the file, mass deletions, mass creations, but change in file size, lots of different statistics. And every time a scan occurs, these analytics are generated, and the analytics of that observation are compared to previous observations. So it looks at how data changes over time. All those analytics are fed to machine learning algorithms that have been trained on all the common Trojans and ransomware that exists in the market today. And you'll basically get a deterministic result that says, hey, it looks like this observation of the data looks good compared to previous observations, or you'll get a, hey, it looks like there's a challenge here. There's suspect files that look like they're being corrupted here. So you'll get like a red light, green light scenario. If you constantly get the green light scenario, that process repeats over and over, and you'll have confidence that the data has integrity and the data looks good. If you get a red light scenario saying, hey, it looks like there's a challenge here, there's a number of forensic reporting and analysis tools to be able to help diagnose and recover from the attack. So in the proactive deployment, there's really a number of things that Cybersense provides, is basically to know when it happens. If you're looking at point in time views or observations of data through the backup process, you'll know that, hey, this backup looks like there's a challenge here, looks like there's a problem here. So you'll know when it happens, versus organizations that continually back up their data. And then when they do get attacked, realize that the backups are not good. And at that point, that's not when you really want to realize that. So constantly check the integrity of the backups. Number two is investigate what happened, the who, what, where, and when of an attack. So who is impacted? How much damage was done? Was it 5 files? Was it 50,000? Was it tens of thousands of files, hundreds of thousands of files? What was attacked? What types of files? Where were they located? A detailed listing of the corrupt files. Where's the source? What user account was used? What ransomware was used to do the corruption? When did it happen? What backup sets contain the last good versions of data? So all the questions you need to know that take all the mystery out of an attack and really streamline the recovery process and minimize the downtime so that you can get the business up and running and operational without much impact. So in terms of the forensic analysis, so post-attack reporting tools. So there's a number of capabilities here post-attack that really support the incident response vendors out there, as well as the proactive deployment environment to be able to help diagnose and recover from an attack. So post-attack, we know that Cybersense can index and scan data. So whether it's proactively or reactively, you need to scan data to look at it and see what happens. Those security analytics are generated automatically, as I mentioned, over 100 of those, and then machine learning is applied to those analytics. That's been trained on thousands of Trojans and over 20 attack vectors. And basically what will be output here is the attack vector. So you'll know exactly what attack vector or what type of corruption is occurring on the data. More importantly, you get a full detailed listing of the corrupt files. So without rehydrating the backup sets here, you're basically going to understand what files were corrupted. Where's the last good version of the file? Where's the corrupt file? So in this case, you can say, hey, is it 5 files or is it hundreds of thousands of files? Where are these files? What servers are they located on? What types of files are they? You can get lots of insight into what's happening. You can take the full file name and full path, and you can use these event log management software to basically ask them the question of, there was 10,000 files that were encrypted. Which user last touched these files? That would be the breached user account. And then what executable was used to encrypt those files? That would be your malware. So you can use those tools to be able to figure out who is executing on this corruption. And then finally, which is the last good version of the file? Where's the last good version of what backup set does it exist on? That streamlines the recovery process significantly. So this is the scenario of Cybersense integrated with the Dell EMC Cyber Recovery solution. This is the Dell EMC Cyber Recovery dashboard. There's lots of different deployment options for Cybersense. This is one that's really selling well on the market today, globally, where the alert comes into this dashboard. So you'll see a red critical alert, which is basically Cybersense saying, hey, it looks like there's signs of data corruption that need to be investigated. Included with these alerts are all the detailed analytics. I mentioned 106 different analytics that exist out there. Here's all the details. You don't really need to look at these, but to get a sense of what Cybersense is looking at, it's looking at file entropy, as I mentioned, file deletions, file size, file extension mismatch, things like that, at a very detailed level. But the machine learning will basically kick out here, this number 6, which is, hey, the data looks like it's infected. Number 6 is an attack vector that Cybersense detects. So it'll tell you the exact attack vector. Cybersense is looking at over about 28 different attack vectors. You can see them listed here. The top 6 are 99+% of what types of attacks are occurring on the market today. The rest of them are stuff that Cybersense looks for, not as common. But most of the attacks are really encryption of data and changing file extensions and corruption in that way. So Cybersense will kick out that information. You can run a report here. So this report is a summary report, and Cybersense will automatically tag the last good version of the file before corruption, and then the suspect file, the file that looks like it's corrupted. And you can see here, if you look closely, you'll see the 0001.doc. That's with the word icon there. That's the last good version. So you can see Cybersense can paste the file and put the word icon there saying, hey, this is a Word document, it looks good. Right above it, you'll see the 0001.doc.fun. So they appended the .fun extension, and Cybersense couldn't even taste the file or read the header. That's why the question mark is there and the icon's not. So the file's been corrupted and they appended an extension on the end. That's a known attack vector. You can always run a series of forensic reports with Cybersense. So you can see on the upper left here, you can say, hey, show me the listing of all the corrupted files. So you can see the corrupted files, get a file count of those. The upper right report will give you the corrupt files per server. So it looks there like server A has the dominant amount of corruption on it. So interesting information, that's where the corruption is occurring. The chart in the lower right corner shows corrupt files by extension. So here, the interesting thing is you can see a number of file extensions are .lol, .encrypted, .fun is also used by ransomware. So you can see that's where your corrupted files exist. And then the lower chart on the center is corrupt files by user or SID. In this case, we're not connected to Active Directory, so you're gonna get the SID, and you can see which user files were corrupted. So lots of detailed information to be able to understand what happened. Again, back to this report that I was talking about is, what are the last good backup sets? So on the upper left, you can see Cybersense can run a report of show me the last good files before corruption occurred. And because Cybersense is capturing all the backup metadata, you can see there on the right highlighted in red, those are the files that were corrupt. That's the file count of all the files that were corrupted, a few thousand files. Basically run this report and say, where's the last good version of all those files? It'll tell you exactly the backup set, backup time for those files that need to be restored. So again, if an attack happens slowly over time, Cybersense will give you all the backup sets. It could be dozens or hundreds of backup sets, but those are the specific backup sets that need to be restored in order to facilitate recovery. So the idea here is you're not creating a clean room and doing the hunt and peck method to figure out where's the last good versions of these files. So in an incident response scenario, you can really understand quickly where the last good versions of files are that exist. That's a very high level overview of Cybersense. If you would like more information, our website's there. There's some information on our website, including a white paper, or reach out to us directly at info@indexengines.com, and we'd be happy to discuss Cybersense in more detail and how we can work together to help prevent and quickly recover from cyber attacks. Thank you for your time today.